Hello and welcome to a lesson on linear sequences. In this lesson I'll explain what a linear sequence is and we'll practice the two types of question that commonly crop up on GCSE exam papers. Our first example of a linear sequence: 5, 8, 11, 14, 17 and so on. It goes on forever. A linear sequence is one where the difference between two terms is the same for each pair. It can go up by a fixed amount each time, or it can go down by a fixed amount each time. But in GCSE questions, it almost always goes up. So the first thing we need to be able to do is find the rule. So how do we get from 5 to 8 and 8 to 11, 11 to 14? The answer is we add 3. So our rule is add 3. We often ask to find the next two terms in a sequence, so that's just a matter of adding on the 3 to 17. 17 plus 3 is 20, and 20 plus 3 is 23. So what else are we expected to do with linear sequences? Well, a common question is to find the nth term. Now the nth term can be any term in the sequence. N stands for any number, 1, 2, 3, 4 and so on. So we want a formula for the nth term. So I'm going to write nth term equals some formula to do with n. Now I want a formula that goes up in threes. Well, how about the 3 times table? What if I was to look at 3n? That just means 3 times n. So when n is 1, the first term, I get 3 1s are 3. When n is 2, the second term, I get 3 2s are 6. When n is 3, 3 3s are 9. When n is 4, 3 4s are 12. When n is 5, 3 5s are 15, and so on. So 3n would give me the 3 times table. But it doesn't quite match. I want 5, not 3. I want 8, not 6. 11, not 9. 14, not 12. And 17, not 15. But what could I do? What adjustment could I make to turn this into 5, to turn this into 8, and so on? Well, I'm sure you can see looking at it that what I need to do is just add on 2. If I do that, the two sequences would be the same. 3 times 5 is 15, plus 2 is 17. And that tells me what the fifth term is in the sequence. So our formula for the nth term is 3n plus 2. But why would we want this formula? Well, we want it so that we can calculate any term in the sequence without writing it out. So my nth term, we've already found, it was 3n plus 2, and that works for any term in the sequence. If I want the 10th term, the number of term is 10, so it will be 3 times 10 plus 2. That's just replacing n, the number of the term, with the term that I want. 3 times 10 is 30, plus 2 is 32. So the 10th term in that sequence would be 32. Find the 25th term. So we just put n as 25. 3 times 25 plus 2. Well, 3 lots of 25 is 75, and if I add 2, that gives me 77. So I've now found the 25th term using our formula. So let's just summarise what we found there then. The rule was add 3. The next two terms we found to be 20 and 23. The nth term was 3n plus 2, and then we used that formula to find the 10th term. 3 times 10 plus 2 is 32, and the 25th term, 3 times 25 plus 2, which was 77. We're now going to go through another 4 examples of linear sequences, and we're going to take this approach. We're going to find the rule, the next two terms, a formula for the nth term, use our formula to find the 10th term and the 25th term. Example 2. 2, 7, 12, 17, 22 are the first 5 terms. Find the rule. Well, to get from 2 to 7, we're adding 5. To get from 7 to 12, we're adding 5. So we're adding 5 each time. So my rule is simply add 5. Find the next two terms. 22 add 5 is 27. 27 add 5 is 32. Now I'm going to look for the nth term. So the nth term, if I want the sequence to go up in 5s, my nth term will be based on the 5 times table. So in the formula we will have 5n. But if I do the 5 times table, that gives me 5, 10, 15, 20, 25 and so on. So what adjustment do we need to make this time? How do we get from 5 to 2, from 10 to 7, 15 to 12 and so on? Well, we can see that to get from 5 to 2 we take off 3. So my formula just needs the adjustment minus 3. Let's check it works for the 5th term. 5 times 5 is 25, take away 3 is 22. Yes, it works for the 5th term, it'll work for all the terms. So now we're going to find the 10th term. 10th term will be 5 multiplied by the number of the term, 10, minus 3. 5 times 10 is 50, take away 3, 47. So the 10th term would be 47. The 25th will be 5 times 25 minus 3. 4 lots of 25 make 100, so 5 lots are 125, and 125 take away 3 is 122. And that completes example 2. Let's move on now and look at example 3. 11, 13, 15, 17, 19. Find the rule. Well, we can see very easily we're just adding 2 each time. Let's find the next two terms. 19 plus 2 is 21. 21 plus 2 is 23. Now comes the bit of maths. Finding the nth term. If the sequence is going up in 2, it will have 2n in the formula, because that's what gives us the 2 times table. Let's write the 2 times table up here. 2, 4, 6, 8, 10. What's the adjustment? How do we get from 2 to 11, from 4 to 13 and so on? Well, I can see we're adding, and what we're adding is the difference between 11 and 2. So we're adding 9. So my nth term is given by 2n plus 9. As a check, let's see if it works for the 5th term. 2 times 5 is 10. 10 plus 9 is 19. Yes, that's right for the 5th term. So the 10th term is 2 times the number of the term, 10, plus 9. 2 times 10 is 20, plus 9 is 29. The 25th term, 2 times 25 plus 9. 2 25s are 50. 50 plus 9 is 59. Move on now to example 4. 1, 7, 13, 19, 25. So what's the rule? We can see that we're going up in 6s. 1 add 6 is 7. 7 add 6 is 13. So the rule is add 6. Find the next two terms. 25 add 6 is 31. 31 add 6 is 37. And now we look to find the nth term. If it's going up in 6s, it will have 6n in the formula, because that's what gives us the 6 times table. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and so on. 24, 30, going up in 6s. We need an adjustment though to make it match the sequence that we have. And inspection here gives 6 take away 5 will give me 1, 12 take away 5 will give me 7, and so on. So the adjustment is -5. Let's just check it works for the fifth one. 6 times 5 is 30, minus 5 is 25, and that matches our fifth term. So now we're ready to use our formula. Find the 10th term. 6 multiplied by 10, the number of the term, minus 5. 6 tens are 60, minus 5 is 55. So the 10th term is 55. The 25th term, 6 times 25 minus 5. 6 25s, well 4 25s are 100, 2 25s are 50, so 6 25s will be 150. 150 take away 5 is 145. And that completes example 4. 11, 20, 29, 38, 47. So example 5, the sequence is going up in 9s. 11 add 9 is 20, 20 add 9 is 29, and so on. So the rule this time is add 9. Find the next two terms. 47 add 9 is 56, and 56 add 9 is 65. Now to find the nth term. If it's going up in 9s, the nth term will have 9n in the formula to give us the 9 times table. Let's write the 9 times table here. 9, 18, 27, 36, 45. So what adjustment do we need this time? We can see that it's simply add 2. So the nth term is 9n plus 2. Should we check it for the fifth term? 9 5s are 45, plus 2 is 47. Works for that, so we can be confident it's right. The 10th term, 9 multiplied by 10 plus 2. 9 10s are 90, add on 2, 92. And the 25th term, that's 9 times 25, add 2. Well, 4 lots of 25 make 100, so 8 lots of 25 will make 200, so an extra 25, 9 25s will be 225, plus 2, so that's 227. If it's on a calculator exam, you could just use your calculator. Right, that brings us to the end of those type of examples. What I'm going to do now is look at 3 more examples on this topic, but they're very different to what we've been doing, because they're based on diagrams. Here we've got a matchstick pattern, and you're given 3 patterns and asked to draw the 4th. Now there's probably only 1 mark for this in an exam, so it's not a work of art. You don't have to get them looking like matchsticks. But all I have to realise is I've got the pattern from the 3rd one, and I've got to add on the next pattern. And I can see that basically I want 3 matchsticks on the end like that. So 1, 2, 3, and that's it. Counting the number of matchsticks, we're adding on 3 each time. Yes, I can see there's 4 here, but 1, 2, 3 have been added on. And then 1, 2, 3 have been added on. So we're just adding on 3s. So we'll have 13 and then 16. The last part of the question says how many matchsticks are used in pattern number 15. Well, let's find the nth term. Doesn't ask us to, but it will be useful. The sequence is going up in 3s, so the nth term will have 3n in it. That gives us the 3 times table, so it would give us 3, 6, 9, 12, 15, and so on. Look at the adjustment required. All I've got to do is add 1 to the 3 times table, and I'll have the right numbers. So the nth term is 3n plus 1. And we've been asked to find the 15th term, the 15th pattern. So the 15th will be 3 times 15 plus 1. Well, 2 15s are 30, 3 15s are 45, 45 plus 1 is 46. So our answer is 46 matchsticks. Next example. Draw pattern number 4. And here it looks as if we're going up in 4s. So what's actually happening? It looks like we're putting an extra 1 in the middle at the top and bottom, and we're putting an extra 1 in the middle down the sides. So I've got 4 going down that side and 3 along the top, 5 and 4 along the top, 6 and 5 along the top. So I'm going to want 7 down the side, 1, 2, 3, 4, 5, 6, 7. And instead of 1, 2, 3, 4, 5 along the top, I want 6. 1, 2, 3, 4, 5, 6. 7 down the side, 1, 2, 3, 4, 5, 6, 7. And 6 along the bottom, 1, 2, 3, 4, 5, 6. How many matchsticks? Well, I'm adding on 4 each time, so I should have 22. Let's do a quick count, starting in the top left hand corner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Right, so that's correct. Add on another 4 and we get 26. How many dots are used in pattern number 10? Well, we've got 2 choices here. We could find the nth term. Let's do that first. The nth term, it's going up in 4s, so we'll have 4n in the formula. That gives me the 4 times table. What would I have to do to get 4 to 10, to get 8 to 14? And I can see that the answer is add 6. So it's 4n add 6, the formula for the nth term. So the 10th term will be 4 times 10, add 6. 4 10s are 40, add 6 is 46. What we could have done as an alternative, because 10 isn't too far past 5, I could have just written down 6, 7, 8, 9, 10 and worked them out. 26 add 4 is 30, 30 add 4 is 34, 34 add 4 is 38, 38 add 4 is 42, and 42 add 4 is 46. And we get the same answer. So if the term you're asked to find is not too far past where you're working, it may be quicker just to keep adding on until you get where you need to be. One final example. Complete pattern number 4. What have we got here? Well, I've got these 2 dots on the outside, left and right. I've got 1 column of 3 there, 2 columns of 3 there, 3 columns of 3 here. So I'm going to want 4 columns of 3. 1, 2, 3, 4, and this outside dot at each end. And we're adding on an extra column of 3 each time. So 5, 8, 11, the next 2 will be 11 plus 3 is 14, 14 plus 3 is 17. Right, so now we want to find how many dots in pattern number 10. Again, we'll look at it both ways. We'll find the nth term, which we should be expert at now. The nth term, it's going up in 3s, so it will have 3n in the formula. That gives me the 3 times table. What adjustment do I need to make? I need to keep adding 2. So it's 3n plus 2 for the formula. So the 10th term will be 3 multiplied by 10 plus 2. 3 10s are 30, add 2 is 32. The other way we could have done it is, as we did in the previous question, just keep adding on until we get to term 10. So 17 plus 3 is 20, 20 plus 3 is 23, 23 plus 3 is 26, 26 plus 3 is 29, 29 plus 3 is 32. So term 10 is 32. And that completes this lesson on linear sequences. We've been through 8 examples which typify what you tend to be asked in GCSE examinations. There's now an exercise for you to do with another 8 examples, very much like the ones we've just done.